Okay, chapter 13-2 is more solving quadratic equations. Okay, example 1, 3x squared equals 18. So this is a little different than chapter 13-1. We don't bring the negative 18 over to the other side because it's unfactorable. Say that you did bring it over, you get 3x squared minus 18 equals 0. You pull out the 3, you get x squared minus 6 in the parentheses equals 0, and then you can't really do anything after that because that is not a difference of squares, so you can't factor it. So we still need to solve this. So we can still solve this. What we're going to try to do is get the x squared by itself and then take the square root of both sides. So on this first part, 3x squared equals 18. Okay, I'm going to try to isolate the x squared, so I'm going to divide both sides by 3. So now I have x squared equals 6. Okay, then you're going to take the square root of both sides. So the square root of x squared and the square root of 6. And there are two square roots, positive and negative square root of 6. And so that's the answer. Okay, the reason there are is because if I take the square root of 36, the answer can be 6, because 6 times 6 is 36. Or it can be negative 6, because negative 6 times negative 6 is also 36. So you write that plus or minus 6. Okay? Okay, example 2, negative 3x squared plus 7 equals 0. Okay, we're going to isolate the x squared, bring the number to the other side. It becomes negative 7. So then now you have negative 3x squared equals negative 7. Divide both sides by negative 3. Okay, then you have x squared equals positive 7/3. Okay, you're going to take the square root of both sides. Okay, now you do have a fraction. That means that you have a square root of 7 over the square root of 3. So you have to rationalize the denominator. Okay, you can't have a radical in the denominator. So you multiply the top and the bottom by radical 3. Okay, and then when you multiply across, radical 7 times radical 3 is radical 21 over regular 3, and it's plus or minus. So make sure all your answers have plus or minus. Okay, example 3, quantity x minus 5 squared equals 9. Okay, we're going to take the square root of both sides, because that whole thing is squared, and the square root of 9 on that side. You get regular x minus 5. Okay, you get regular x minus 5 equals plus or minus 3. You're going to take the negative 5 and bring it over. It becomes positive 5. You're going to put it in front of the plus or minus. Okay, now I have x equals 5 plus or minus 3. Now these are both regular numbers, so you actually have two answers. The first one is 5 plus 3, and the second one is 5 minus 3. So the two answers, 5 plus 3 is 8, and 5 minus 3 is 2. Okay, example 4 is like example 3, except now we can't really take the square root of 7. So I have quantity x plus 2 squared equals 7. I'm going to take the square root of both sides to undo the squared. I get x plus 2 equals plus or minus the square root of 7. I take the 2, bring it to the other side. It becomes negative. Put it in front of the plus minus. So you have x equals negative 2 plus or minus the square root of 7. And we're going to leave it like that because you can't take the square root of 7. So the two answers are negative 2 plus radical 7 and negative 2 minus radical 7. Okay, on 13-1 we would have brought the 17 over to the other side, but then you get x squared plus 16x plus 47, which is not factorable. So we're going to look at the left side and see if it is factorable. we have 64 and 16. So yes, it is factorable. It's 8 times 8 is 64, and 8 plus 8 is 16. So then really on this left side I have x plus 8 squared, because it's x plus 8 times x plus 8, equals 17. You're going to take the square root of both sides. Okay, then when you do that you get regular x plus 8 equals plus or minus the square root of 17. You bring the 8 to the other side in front of the plus minus. So now we have x equals negative 8 plus or minus the square root of 17. So the two answers are negative 8 plus radical 17 and negative 8 minus radical 17.